One such formula is called the compound interest formula, and it can be used, for example, to calculate the balance or the money that's accrued in one's savings account. The formula looks like this. A equals P times quantity 1 plus R divided by N raised to the power of N times T. The formula looks somewhat intimidating, but once we decide what these variables stand for, it makes the formula a lot easier to understand. For instance, the capital P is the principal amount of money that one is borrowing or has deposited into a savings account. The lowercase r represents the annual rate of interest, and it's written as a decimal. Lowercase t is the number of years the amount is to be deposited or borrowed for. Capital A is the amount of money that's accumulated. Lowercase n is the number of times the interest is compounded per year or annually. Let's try an example to make sure we understand how to manipulate this formula. Let's say, for instance, that a person is going to deposit $1,500 into a savings account. The bank is paying an annual interest rate of 4.3%. This is compounded quarterly. What will the balance be in that account after 6 years? In order to use the formula, we have to give values to the variables. So in this instance, the principal amount is going to be $1,500, so capital P is equal to $1,500. The annual interest rate is 4.3%, and in order to change that into a decimal, we have to divide 4.3 by 100, and the decimal equivalent is 0.043. The number of times that the interest is going to be compounded per year is 4 times. Since it said, the problem states that the interest is compounded quarterly, which means 4 times per year. And then the number of years that the amount is deposited or borrowed for is going to be 6 years. In order to do the calculations, we need to use the correct order of operations. So we should work what's inside the parentheses first. We'll take our percentage rate, which is 4.3%, and divide that by 4, which is the number of times that the interest is compounded annually. We come up with an answer of 0.01075. We add that to 1 and get 1.01075. We're going to raise that quantity to the 24th power, and we come up with 1.292557881. We multiply that times our principal, which is 1,500, and we should come up with an answer. The answer will tell us what the balance will be approximately in 6 years of our savings account. If we started out with $1,500 principal and we left it in a savings account for 6 years, if that interest is compounded quarterly, we should have approximately $1,938.84 in our savings account after 6 years. That looks like we've actually made approximately $438.84 in a 6-year period. That may not seem like much, but if you think about it, you actually made that money without doing any kind of manual labor. So that actually turns out to be a pretty good return on an investment. Once again, the balance in your savings account is $1,938.84. We were able to calculate this by putting algebra to use. We used an algebraic formula called the compound interest formula, and it gives us a calculation or an approximation of how much money we'll have in our savings account, in this case after a 6-year period. Many of the calculations that we use in everyday life are derived from formulas that we get from algebra. After all, a formula is an algebraic rule for evaluating some quantity.